Yeah, welcome to the world of mobility. My name is Michael Peter. I started 1991 with mobility, and for 10 years I've witnessed how slowly that industry was innovating. Not because we had worse engineers, but just because the safety requirement, environmental requirements are so high that once you have an homologation that costs you many millions, you just don't touch it anymore for the next 30 years. And then in 2000, I changed to what was then called Siemens Industrial Solutions. So I was basically the house internal system integrator to DI, using their products to build factories in different areas of the world. And of course, the big buzzwords then were IoT technology, bringing IP into the industrial world, and we were so far behind in mobility because of the reasons I said. 2010, I rejoined mobility. Last time I talked to some of you probably was Capital Market Day 4 years ago, and I said these are the most exciting times in the market because we now bring in the latest technology into our portfolio. And when it used to be completely proprietary, now we're opening it up. And I think what I said exactly became true. And I would actually dare to say now are the more exciting times than the most exciting times. And let's have a look at the market, what that means. The market did exactly what we predicted. Global trends like population growth, like urbanization, give us a very clear prediction that travel volumes will double by 2050. And that was a time, of course, 5 years back, when CO2 emission reduction was already a big item. Some cities were closed because of the diesel emission discussions. So it was clear that cities and governments were going to look for solutions. And you see that here on the market, a very stable growth also predicted in the future. And you see the gray area, which is not the classic growth, but it's investment of cities like Frankfurt today replacing everything, or like countries, Egypt, looking how to transport the next generation. And when that happens, the second big consequence of that is that these customers will not look for the cheapest product. They will look for a product, when we talk about infrastructure, that gives you more capacity on the rail without drilling a new tunnel or putting new rail in a city where that is impossible or would be really, really expensive. So they will look to invest reasonably, but with focus on yield. The same on the rolling stock side. When you build a fleet or you buy a fleet for a whole country, then you will not look at the cheapest purchasing price. It needs to be in the right dimension, but you'll look for energy consumption. You will look for low maintenance costs. You will look for the train being on the track as much time as possible. And you will look for a digital experience drawing people into that train, because you can't force people by law to use a train. And that's exactly what happened. And that's where our technology leadership strategy was built on. That's where we went through the foundational technology, as I will explain, and the results you will see here. We gained 4% in market share, and that means from 13 to 17%, which is, to me, unbelievable in a slow-moving industry of mega projects or large projects. It led to our backlog growing from 24 to 52 billion. And Ralf Thomas mentioned it with an increased profit, gross profit margin within that backlog, because we sold technology. We didn't sell lowest bid. Revenue grew by 8% per year over the last 5 years, and we have a very stable prediction going forward because, of course, much of the upcoming revenue is already in our books today. And last but not least, we converted into profit and into cash. And that's really remarkable in an industry where the customer has all rights many times to withhold payments, because these contracts are complex and give a lot of rights to the customers. But when the customer feels you have delivered what you promised, they do pay. And we have a cash conversion rate of 1.06 over the last years. Let's look at that strategy that I referred to. And I think it all starts with the middle one on the lowest level, focused portfolio. We decided to play where technology can make a difference. Technology that we call internally foundational technologies. These are Siemens technologies coming from the broad knowledge pool and research pool of Siemens. And we said where this technology can make a difference in those 4 levers, when it can provide you more network capacity on infrastructure, where it can give you better booking rates for your booking, seat booking service as an operator, where it can bring you more availability, then this is where we want to play. And these foundational technologies that are listed or made the difference in these levers, these go really from simulating the product itself, simulating how we manufacture it, about the product itself, the project being very digital. Many times we talk about a computer on wheels. An ICE high-speed train has about 10,000 sensors. What can we do with this data if we have the right architecture? They go into, of course, IoT, as I mentioned before, but at the end of the day, what I didn't know 4 years ago is that AI will probably change everything. And what was our strategy then will be the foundation going forward to actually use AI in a way that our competitors cannot do it because they don't have the same access. If you do this right, you have a second big advantage. You can scale your factories. We are really proud that we have the least factories in the world from all of our competitors, substantially lower numbers. And that's because we specialize them. In Munich, we produce locomotives and only locomotives and the coach cars that belong to them. And we produce them in a very, very high number so that we can invest in welding robots, that we can invest in building up a digital twin of what we manufacture, like a digital twin passport that then goes into the service of the train once we sold it. Yeah, and on the top, of course, I talked about the importance of data architecture, our accelerator strategy that we launched about 3 years ago. When you do all of this, you will realize that proprietary projects with individual data architectures in every project really limit you in learning what your products do. So for us, it was very important, and that's when Accelerator came around, to define architectures and make sure that we have access to the data that we produce, that our software is modular, so we can innovate small modules. We don't have these huge monolithic software things anymore. And that in the end of the day, our target will be to bring that software into the cloud. And when you do that right, actually, one of the big effects that you have is that you stay in contact with the product. So when I look at what does this focus on portfolio mean, I've talked about rolling stock and infrastructure, but the beneficiaries are, of course, customer service and software, because they can now use that data. They can use that data to stay in touch with the product and to recommend customers what to do with the product. Or we have a much higher booking rate, for instance, on trains. And here I want to tell you a little bit about why we're investing so heavily into our software business. I think this is by far the underestimated lever in the transportation industry. An average long-distance train in Europe has a booking rate of seats of 50 to 60%. The train leaves the station, the cost is exactly identical if you have full booking. Imagine a company that with the same cost can add 40% revenue, 30% income, what that means for your equation. Generally speaking, in Europe, it would mean you wouldn't have to subsidize tickets anymore, because roughly every dollar on a metro ticket is subsidized by $1 or by €1. It would become a self-financing system. We achieve booking rates of 97% with our software because we know what's going on in the train. We can facilitate seat reservations. We can allow seats to be changed just before the train leaves, but we have transparency. For rolling stock, it had quite some big impacts. We focus on rolling stock where we can sell what we call platform to many customers, with all the advantages that comes with spare parts identical and so on and so forth. And I'll explain to you what a platform is later. But that means we can spend 150 million euros on developing a new train type that is completely digitized, that our competitors cannot do in the same way. It also meant that you will not see us bidding very much anymore on light rail vehicles or metro vehicles. If you check, almost nothing won by Siemens. What we do there is propulsion systems, the electronic part, because that's where we can still scale underneath. But if the train has to look different in every city and it's every time units 20, you cannot spend 100 million on making it a digital product over the life cycle and then actually build up a business model that we want to actually have an ecosystem for that. Yeah, and revenue on rail infrastructure is also very simple. We are the first ones and the biggest ones contributing to the development of global standards, be it ETCS on the main line, be it CBTC on the cities. And we do that in a way that we can later on again develop modular software on it. And we focus on these, having in mind already, we do want to bring them in the cloud, and I'll show you later where we are on that. And of course, we love combining all of this in a turnkey project. A very good example is the Vectron, where we really flipped the market. Locomotives used to be a custom designed thing for every customer. We developed it into a product and then actually into an ecosystem. What do I mean? We start by developing a locomotive with the idea it has to run in 20, 30 countries. So it becomes a modular locomotive. We already look at how can we produce it when we do this. If you go to Allach, you'll see the roof goes on last on our locomotives. What goes in is modules for the different voltage systems in Europe. In the future, we will have a battery module that can go in. When we're done with all of this, then we put the roof on. So it goes from designing with digital tools over manufacturing to be a modular product. When that's the case, we can manufacture it in a really almost automotive-like style. Today we have almost 2.5 locomotives being manufactured every day. And that, of course, allows us to use then DI technologies during the manufacturing process in a way that you usually cannot do when you build unique little solutions. Then everything becomes a manual labor, just like in manufacture. Now, when you've done all of this, and this is where I said it starts flipping, the system starts flipping, you have a product that has a residual value. If a customer buys that product and he doesn't want to use it anymore after 3 years in this country, he can use the same product somewhere else. He can even change the bogie. The bogie is modular. It can be for freight with a lower speed, higher torque, or it can be high speed for passenger service like Flixtrain is tending to do. So when that happened, actually, we had investors, leasing companies interested in buying our locomotives. We have sold today 2,800 locomotives. 2,200 have been delivered. 80% of them were sold to leasing companies. And we believe we are in an absolutely unique position that we sell these locomotives to leasing companies because then at the end they can use them in many different applications. And what that means again, we can finance it. We have sold over 1,000 of these locomotives with financing included from SFS. The word ecosystem that I use is particularly important because we stay in touch with this locomotive all the time. We collect all the data of the locomotive and we can tell the operator how to change its operational mode to reduce wear, to use it on different tracks also that the wear is even. We can tell them you should go to service. And by the way, the next service station is very close to you because when you have sold 2,800, you're the only one in Europe that can have service stations where the locomotive runs. They don't have to come to Allach. They can stay south of the Alps where all these freight corridors meet and they can do it there. And what that means in effect, actually at the end of the day, is maybe best explained by saying that this locomotive has a sales price, but the service cost over the life cycle is over 1 time the sales price. 2 examples, what a digital product means, one from rolling stock and one from infrastructure. Rolling stock, the newly designed Velaro Novo. Siemens invented the locomotive, electric locomotive, 1876, over 105 years ago. So when I go to my engineers and say, let's do a new high-speed train, I would expect 5% improvement. But what's happening right now is we have a real revolution using Siemens technologies, and again, that not everybody in the market has that easy access to, and that we can we use here that actually lead to 30% energy savings. I want to give you a little bit an impression of how this is possible. A high-speed train has 0 friction, basically. The bearings are so good, the steel contact on the wheel to the rail is almost 0. When you shut power off, it'll roll 150 kilometers without stopping. So it's about weight reduction, it's about semiconductors, and it's about airflow. Airflow being the biggest. All 3 of them are Siemens foundational technologies. And you see here, of course, the typical airflow simulation you would do, but I want to point you to this. We have developed a new propulsion system that builds so small that we now can actually close the underneath completely. So all you see is 4 wheels. So the air can flow so smoothly that in the end of the day, we have 30% energy reduction. And by the way, when you buy a high-speed train, 1/3 is purchasing price. Today, 1/3 is energy costs over the life cycle, and 1/3 is maintenance. So if you save 30% energy, you should be allowed to be 20% higher in the purchasing price, which we are not. Our cost position is very reasonable here, but it's a huge leverage for our operators. We still don't allow us to call this a platform until actually we know we can use it for many, many customers. And this is where this comes into play here. A platform of our trains means it's an empty tube. The customer, the operator, can define what they want inside and what they want to operate. We have offered trains currently in a little bit of a wide body that have 5 seats. So they have more seats because there's no stairs and nothing. than the double-decker competing against with us, even though it's a single deck. They have more seats than them. But you can also put a launch car in here, or a party car, or a bar system, so you can do whatever you want to do. And that's when we start calling it a platform, because you can use it for really low-cost competition. You can use it for high-end services, and it can be reused many, many times. Infrastructure. I also want to go a little bit in technology. What we have today in Europe is roughly 15,000 of these houses, each one filled up with relays and electronics, because every 15 kilometers you have an interlocking. And when a train drives from Munich to Berlin, you probably cross 30 times a border of this interlocking. You have a handover procedure and. So what we did in Norway, and I wouldn't call it evolutionary, I would call it half a revolution, is we do a IoT architecture. So our point machines 800 kilometers away from Oslo are controlled from an interlocking that is actually in Oslo. So now when that point machine has a problem because it puts snow together, we will realize that in Oslo. We will see that the power consumption goes up, and we can control it and service it from there. And what it means for operations is that this train, from now on, can be scheduled as one train between Hamburg and Berlin if we have this technology. I read just a week ago in a newspaper that the operator in Norway has said they will in the future only need 1/10 of their operators. And that's really the tip of the iceberg, because this is not about saving the operators, but it shows you how much more efficient the scheduling will be. It will increase the throughput on the line, and it will bring delay minutes down, because every time you have a handover, of course, you can make a mistake. And on the right, this is the second part of what really is a revolution. We're moving that to the cloud, where you have 15,000 houses that are half the size of this room here, full with electronics. In the future, we will have one server in the cloud. And we have outside an example for you that actually is being used for a demonstration that we did in Singapore that Roland also mentioned. Now, where are we with this? On mainline, we have the interlocking in the cloud as a technology. Interlocking is simply avoiding green on green. We have the ETCS in the cloud, which is actually how do I schedule my trains, when do I request this line must be reserved for me, which is both safety relevant. And we have the same on the mass transit, the interlocking and what there is called CBTC. And what we did in Singapore is we put all of it on one cloud server, and that's what we call Signaling X. Now you can schedule the whole line in one computer. You have access to all of this data. You have the CBTC on the same computer, and we have the OCS on the computer. And when you go out there, it's about this big, and you could probably run the whole city of Singapore, all the metro lines on that hardware. Where we have sold it on mainline in passenger service in Achau. We've sold it also in countrywide rollouts in Europe already. In the mass transit, we're introducing it right now. Currently, we have almost 60% of our portfolio transferred, so it could run in the cloud tomorrow. Many times we're approaching our customers now, instead of buying spare parts in Norway, just give us a license for the DS3, and then you can buy your server wherever you want to buy your servers. That makes much more sense to the customer because they have increased functionality and efficiency of the system. Yeah, summarizing it real quick. It's all about focus for us. We play where our Siemens technologies give us an advantage over the competition, over the life cycle, over energy consumptions, over throughput, capacity, and all that. That leads us to a manufacturing footprint that is unique in the industry. And when we grow and build a new factory, it will never be a copy. It will be more modern, and it will take portfolio out of one factory and allocate it exclusively here. So also the old factory will be more specialized and better in the future. And maybe one thing I haven't talked about at all, sustainability that I want to end with, because that is why our customers are investing. That's why the market is what it is. We calculated the carbon reduction that the portfolio that Siemens Mobility brings into the market over 1 year. And it's an unbelievable 100 million tons of CO2. It's 1/6 of the carbon emissions of Germany. So I calculated we have 43,000 employees. Times 6, if we had 250,000 employees in Germany working on a portfolio as impacting on carbon reduction as Siemens Mobility, we would basically compensate the footprint of Germany. This is what our industry can contribute to the targets of governments, of cities, and that's how our market works. Thank you very much.